All right, in this section, we're going to start talking about probability. In the previous worksheets, we studied sets and logic, where we categorize different stuff into different sets, which are basically groups, and investigate the relationship between sets. We did intersection, unions, and all this stuff. And we investigated the relationship between statements. So we look at conditional statements, valid argument, invalid argument, all this stuff. In this module, we're going to do something slightly different. We'll look at the relationship between sets, but in a numerical way. We'll now refer sets as events and investigate the likelihood of certain events occurring. So I'm going to go over some of the terminologies we're going to use throughout this module. All right, so first it's called probability experiment. Most cases I'm going to just say it's an experiment, but sometimes I'm going to refer it as a probability experiment. It's a situation where the outcome is determined by a chance, meaning that we don't know for sure what the outcome of the experiment is going to be. For example, flipping a coin to see if it lands on head or tail is an experiment. It's determined by a chance. I don't know if it's going to be head or tail for sure, right? So that's just one of the most common examples of an experiment. An event is a collection of particular outcomes. It can be outcome or outcomes of an event because it's a collection of steps. Basically, it's a set. As I mentioned before, in this section, we're going to refer a set as an event. They're basically the same thing. It's a collection of steps, collection of outcomes. A simple event is an event that cannot be broken down anymore. It basically contains only a single outcome. A sample space is a set of all simple events. It's usually denoted by the capital letter S. It contains all possible outcomes of the experiment. So basically, it's a universal set. So here in probability, universal set is called a sample space, and a set is called event. The probability of an event E is the likelihood of E occurring. Is denoted by P of E. So instead of writing probability out, a lot of times you're going to see just P, and then we'll have parentheses and put whatever is there, try to find the probability of inside the parentheses. So we can calculate. This is like most common way to find the probability of something, which is likelihood. So if you have a lot of stuff in your event, it's more likely to happen. If you don't have that much stuff in your event, it's less likely to happen. So how do I actually say that? So probability of E is number of outcomes corresponding to E, corresponding to, oh my gosh, a lot of writing, and then number on the bottom, number of outcomes corresponding to S as in sample space. Basically, it's a number of simple events in E over number of simple events in S. All right. So count how many things are in E over count how many things are in S, which is everything. All right, let's look at some example. Let's look at number 2. It says, consider a probability of experiment of rolling 6-sided die. Write out the sample space. Okay, it says 6-sided die, so it just basically has 6 sides, has number 1 through 6 on it. So sample space again is all possible outcomes, or you can think of it as a universal set. So that's 1, it could be 2, it could be 3. So think of all possible outcomes when you roll a single die. So 1 through 6, okay? Part B says, let A be an event that 5 shows up. All right, E is an event that even number shows up, even number 5. B is the number less than 6 show up. Write out the event A, event E, and event B. All right, so event A, it says 5 show up, so just 5, that's it. So let's say you're playing a game, whatnot, you want 5 to show up, that's the event that you're looking for. It could also be possible that you're looking for even number, so that could be 2, 4, or 6. So notice that some events just have one thing in it, and some events have 3 different elements. And then what else is there? Event B is says number less than 6 shows up. So it's a 1, 2, 3, 4, 5. Okay, I'm not going to write 6 because less than 6 means not 6, but it's less than 6. Okay, so those are 3 possible events. And it says to calculate the probability. So probability of A. So again, kind of looking at the formula, it says just count how many elements are in A over the whole sample space, which has 6 elements. So this is going to be 1 over 6. Because A has only 1 element. And 6 because S has 6 elements. You'll notice that basically all probability question here for the die, the denominator is going to be 6 because that's the sample space. Let me do one more. Let's do B. Let me do part 4. This is probably B complement. Well, B is 1 through 5. So complement again is like the opposite. So that's just 6. That means there's only one thing in it. So I'll write that. All right, let's do one more. I'm going to have you finish the rest of it. Let's look at part 6. Probability of E and B. Again, in order for something to be in A and B or E and B, have to be in both sets. So I'm looking at set E has 2, 4, 6. Set B has 1, 2, 3, 4, 5. So I want to find the elements that are in both E and B. So that's the common elements. So it'll be, let's write that out. So E and B, basically this E intersection with B. If I write that out, it'd be 2. They have 2 in common. They have 4 in common. I think that's it. So probability of E and B will be 2 over 6. 2 because there are two elements in this set, right? Okay, I'm gonna have you pause and finish the rest of number 2 and number 3, and I think I can do number 4 as well. And we'll meet back at by the deck of cards. All right, so here's a picture of deck of cards. Many probability questions come from selecting cards from a deck of cards. So let's take a look at the picture here. Maybe some of you guys are familiar with the decks. Maybe some of you aren't. Just want to kind of go over this. Right, so you notice. So let's look at this. Please notice the following. There are how many different suits? There are different shapes. So you see there are 4 rows, and each row has the same shape, which is called suit. So there are many different suits: clubs, spades, hearts, and diamonds. And as you can see, the clubs and the spades, they're black, and the hearts and diamonds have red color. So sometimes I'm going to refer cards as black cards and red cards. Then you know which suits that we are referring to. Each suit contains 13 mini cards. You notice that the first card has the letter A on it. It's called an ace. For some game, that's the highest rank. Some other games, it's the lowest rank. So it depends on what game you play. It could be like the highest number, or it could be the lowest number. All right, let's look at the part E. The last 3 letters, you can notice that the last 3 cards have letters on it. Those are called face cards. They're called face cards because they have face of something on it. They contain letter J for Jack, Q for Queen, and then K for King. So these cards are referred as face cards. All right, so let's look at the next question. It says, find the probability of a face card. So here, let's look at the face card. How many are there? There are 3, 6, 9, and 12. So again, probability, I'm counting the number of elements in the face card set. So there are 12 of them, and a total of 52 cards. So it'll be 12 over 52. Let's look at one more here. Let's get one with the OR. Okay, let's get part C. This is ace OR face. So let's look at the set. There's ace OR face. Again, this is OR, so I'm merging, putting two sets together. So here, you don't have to write it out. I'm like writing it out, but you can visualize it. We have 4 aces, right? And then we have JQK, 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 JQK. I'm writing everything out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know I said there's 16. Again, I have to write it out. I could have just counted in my head, but if you don't feel comfortable, you can always write it out, obviously. So this will be 16 over 52. Okay, I think that's it. I'll have you pause, finish the rest of the worksheet, and I think we're done.